Family of courses in the cement industry. Present to you. To the friends of courses in the cement industry. I hope to subscribe to the membership, so that we can continue to provide useful content. In this course we will detailed explanation. Sulfur, chlorine, and alkalis. In cement rotary kilns. 1. Type of cycles in dry rotary kiln system. Internal cycle. 1. Chloride salts are evaporated, start to travel through rotary kiln system. 2. Salts will be condensed, precipitated on the new feed in the preheater, and will travel back to the rotary kiln. 3. It will start new round of cycle, which will continue as long as the rotary kiln is in operation. External cycle. 1. When vapor of the volatile materials condense on rotary kiln feed particles, leave the rotary kiln with rotary kiln exhaust gas either to rawmill area, and applied raw materials grinding process. 2. Also, when these gases laden with dust that enriched with condensed volatile matter, sent to main filter of rotary kiln and rawmill main dedusting, the dust will be precipitated and collected and transported to rawmill homogenizing silos, and will enrich rotary kiln feed with volatile matters. 2. Chlorine cycle in rotary kiln system. What happens inside a rotary kiln? 1. Nearly 97 to 100% are evaporated in burning zone. 2. When chloride will evaporate in the rotary kiln system and combined with alkalis, its salts will melt at 800 degrees C or even. 3. When these chloride salts are mixed with sulfate salts formed in the rotary kiln, then melting point of the mix will decrease, to less than 700 degrees C. 4. An internal cycle of chlorides will start in the rotary kiln, and chloride salts will travel to rotary kiln with feed. 5. Vapor pressure will starts to increase with increased concentration of the salts, until boiling point is reached. 6. This boiling will take place in rotary kiln burning zone. 7. And all of the chloride salts will eventually evaporate in the burning zone, and will travel to rotary kiln inlet and to preheater, with drafted gases of the rotary kiln. We follow together, chlorine cycle in rotary kiln system. 8. So, all chloride salts are trapped in rotary kiln system. 9. Virtually no chlorides will leave the rotary kiln with clinker, when compared with sulfur salts that nearly 40 to 45% will leave with the clinker. 10. Chloride salts will stay in the vapor state until reach cyclone stages in the preheater, where it condenses as solid salts. 11. The vapor pressure will start to build up in the system of the rotary kiln, until the concentration chloride salts and other sulfate salts will be higher in rotary kiln atmosphere more than rotary kiln feed fuel and clinker. In some cases, the concentration can be 100 times more than the concentration of chloride in the fresh rotary kiln feed. 12. In such cases we have to break the cycle. 13. This will require bleeding of rotary kiln gases before it enter the preheater laden with these gaseous chloride salts. We follow together, chlorine cycle in rotary kiln system. 14. This action of bleeding will be called bypasses of rotary kiln gases to prevent it from entering the preheater. 15. The effectiveness of bypass is closely related to chloride salt cycle. 16. The bleeding of rotary kiln gases carrying these salts will be increased, until the bleeding will be enough, and sufficient to take out the equivalent amount of chlorides, that is entering rotary kiln with the feed and fuel in case of coal. 17. This will reduce the concentration of the recirculating chloride salts, and with this reduction their capacity to block the preheater riser ducts, and hot meal pipes and cone of cyclones will be greatly diminished. 18. When the concentration of chloride in the raw meal is more than 0.015%, then the possibility of having a bypass system should be considered. 19. This will also be applicable when alternative fuel rich in chlorides are applied as source of thermal energy in rotary kiln. 3. Sulfur cycle in rotary kiln system. What happens inside a rotary kiln? 1. Short dry rotary kiln with preheater and precalciner capturing a higher percentage of sulfur, introduced into the system and tend to circulate it more than long dry, or long wet rotary kilns. 2. The different factors that control generation of sulfur oxide, and its reaction with materials inside rotary kiln system must be understood in order to control it, and control its impact on dry rotary kiln system. 3. Sulfur in the system that is introduced by fuel in most of cases, will be oxidized and SO₂, produced is reacted with the rotary kiln feed, and taken out with the clinker. 4. While sulfur introduced into the rotary kiln through rotary kiln feed, will be mostly in the form of sulfates that will react with rotary kiln feed, and leave the rotary kiln with clinker. 5. When sulfur in rotary kiln feed will be in the form of sulfur, sulfide, polysulfide. That its source is pyritic sulfur will be oxidized to SO₂. 4. Behavior of sulfur compound in rotary kiln system. 1. One of the most important factors that determine how much of sulfur is captured in the rotary kiln system, and how much emitted from it is the presence of oxidation, or reduction condition in the rotary kiln system. 2. In some rotary kilns identical with the same type of burner and same materials in the same plant, one can find sulfur in the clinker is about 1.1 to 1.2%, while the other rotary kiln sulfur percentage in the clinker will be 0.35 to 0.4%. 3. In the first case there is oxidation condition in the rotary kiln, in the second case and reduction condition. 4. One of the worst mistakes in regard to rotary kiln burner is to permit for a direct contact between the flame and the materials under this flame. 5. This will permit for very high evaporation rate of sulfur from these materials. We follow together, behavior of sulfur compound in rotary kiln system. 6. As a rule of thumb, the more chlorine in rotary kiln feed the more the volatility, since chlorine tend to combine with alkali, and then will be evaporate again in the burning zone. 7. Therefore sulfur will not find enough alkali to combine with, and leave the rotary kiln. 8. The result will be more alkali circulates in rotary kiln system. 9. Therefore alkali and sulfur ratio has a great impact on circulation of sulfur in the system, since with it is the value of 1, then there are enough alkali components that will combine with sulfur, and will tend to leave rotary kiln system with clinker. We follow together, behavior of sulfur compound in rotary kiln system. 10. Another rule is that the easier the burning of rotary kiln feed, the lower the amount of sulfur that will evaporated and circulate in the rotary kiln system. 11. In the burning zone and alkali sulfates are mostly leaving the rotary kiln, with clinker in normal operation condition. 12. In transition zone in the rotary kiln, the sulfates will not evaporate from the calcined hot rawmill. 13. In calcination zone in the rotary kiln, SO₂ will tend to be highly reactive with calcined rotary kiln feed. 14. In rotary kiln inlet area, absorption of sulfur compound will be slow. 15. In electrostatic precipitator and dust collector of rotary kiln, and rawmill, part of SO₂, will be removed from the system by the dust and through the chimney. 5. How to control sulfur in dry rotary kiln system. 1. Part of the sulfur, alkali and most of chlorine introduced into rotary kiln system are evaporated from rotary kiln feed in different part of the rotary kiln system, and in the area of main burner and precalciner burners. 2. the remaining amount of sulfur and alkali, and in presence of chlorine if it exceeds certain limit, it will tend to accumulate in the system and circulate. 3. By time higher concentration of these components will accumulate in the system. 4. In such condition the behavior of these components will with affect operation conditions in rotary kiln and in preheater. 5. Such situation will require an installation of a certain type of equipment, that will bleed rotary kiln system gases, and remove with these gases these system adverse materials. We follow together, how to control sulfur in dry rotary kiln system. 6. This system applied in this case is called bypass system. 7. This system will prevent of undesirable buildup of excess alkali chloride, and alkali sulfate in the dry rotary kiln system. 8. Oxidizing condition in burning zone reduces the evaporation of sulfur, alkali and permit for them to leave the rotary kiln with the clinker. 9. The evaporation of sulfur will not be affected much by its concentration in the fuel, or the amount of circulation of sulfate in rotary kiln system. 10. But it is mainly dependent how much of the sulfur is in the form of sulfide, and organic sulfur, since this organic sulfur will behave in the same manner as sulfide, and they are also evaporating at lower temperature 400 to 600 A degrees C. 6. Sulfur in rawmill applied as rotary kiln feed gases from preheater, will usually be applied for drying purpose of rawmill. 1. Material in rawmill area. The hot gases will usually contain variable amount of sulfate components. 2. If there is excess sulfur, then very small part of it will partially react to form calcium bisulfate. In case 1. In the upper part of the preheater, where temperature will be in the range of 300 to 600 A degrees C, the absorption of sulfate by the hot rawmill is relatively poor. The calcined materials in rotary kiln and precalciner will absorb a high amount of sulfur oxide, and carry it out to the preheater again, and creating the cycle of sulfur in the rotary kiln system. 2. In the calcination area of the preheater, where the temperature will be in the range of 850 to 900 A degrees C, the sulfur tend to react in a very quick and very effectively, with the calcium oxide newly formed in the precalciner. It will return back to rotary kiln with rotary kiln calcined, and rotary kiln feed. 7. Transition zone in rotary kiln. 1. In this area, if it is enriched in oxygen and proper heat profile throughout rotary kiln tube, then sulfites tend to become more stable, and so too, will continue to be as vapor, and with increase oxygen melted sulfates, solid sulfates, and SO₃, will be more stable and mostly will leave with the clinker. 2. Sulfur oxide will combine with alkalis to form potassium sulfate, and sodium sulfate, and these components are very stable. Therefore, the sulfur oxides represented mainly in SO₂, and SO₃, will be combined with alkalis to form alkali sulfates. This reaction will be favorable with proper condition of heat profile in the rotary kiln, proper ratio of alkali to sulfur, and higher concentration of O2, and very low concentration of Co, since Co destabilize alkali sulfates components. Conclusion. 1. Alkali chlorides and sulfates exist in raw materials, from which rotary kiln feed is manufactured in rotary cement plants. 2. Sulfur is also introduced to rotary kiln system in case of using heavy fuel oil. 3. Their concentrations vary in raw materials deposits in a very high range. 4. In some deposits they will be present in minimum concentration, or acceptable or exceed certain limits. 5. In such type of deposits, it will be a must to have a certain installation in rotary kiln system that is called bypass system, in order to achieve a smooth rotary kiln operation. We follow together. Conclusion. 6. When the concentration of these elements is not reached in saturation in rotary kiln system, they will deposits on the materials in solid condition. 7. If these salts reached saturation conditions in rotary kiln system, then they will start to deposit in partially salt liquid phase, namely, NaCl, CaCl, Na₂So₃, K2So₃, CaSO₃, and these salts will adhere to the walls on rotary kiln riser ducts, cyclones, and hot feed pipes. 8. They will be in partial fusion, and they will be found in area of rotary kiln system represented in area, where the temperature range is 700 to 958 degrees C. 9. Two salts, namely spurate and sulfospurite, are formed, and causes this change of properties. 10. Pressure measurements in the cones of the cyclones, and the difference between the temperature of the gas and the material's temperature should be used. We follow together. Conclusion. 11. The concentration of Na₂O and chlorine in rawmills applied as rotary kiln, and will not cause any harm to rotary kiln operation condition are: Cl equals 0.015%, Na₂O equals 0.6%, SO₃ equals 0.45%. 12. If the concentrations of these materials exceed the following concentration, rotary kiln operation will start to face difficulty in having smooth operation. Cl equals 0.025%, Na₂O equals 1%, SO₃ equals 0.475%. 13. If the concentrations of these materials exceed the following concentration, rotary kiln operation will be next to impossible without bypass system. Cl equals 0.05%, Na₂O equals 1.65%, SO₃ equals 1.4%. Important note: limits can be changed and even lowered, if the heavy fuel oil will contain more than 3% sulfur. Alkali and sulfur cycle in rotary kiln preheater. See in this picture. Paths of both. 1. Rawmill. 2. Gas. 3. Solid. See in this table and picture. The intensity depends on volatility of species. 1. Chlorine, Cl, 97 to 100%. 2. Sulfur, S, 30 to 80%. 3. Potassium, K, 10 to 70%. 4. Sodium, Na, 5 to 40%. See in this picture. Cycle bypass system. See in this picture. Example of SO₂ balance. Thanks for following the channel, Courses in the Cement Industry. And please help us to continue and provide more information, by subscribe to the membership, and inviting your colleagues to watch this channel.